This is section 10.1 on adding and subtracting radicals. So a little bit of background on this. If we're going to add 1x plus 1x, we're going to get a value of 2x's. Notice the exponent stays the same. We just add the coefficients that are in front. Next, when we have more variables, we can combine the like terms. So there's 2x and 1x, which make up 3x. Negative 3y plus y gives us negative 2y. All right, so a little bit of review. In order to add or subtract, the terms must be the same. So when we apply that same principle to radicals, that's with the little square roots on them, we have to make sure that the number underneath the radical is the same. So as we're adding this one, 3 square root of 2 plus 5 square root of 2, we're going to have a total of 8 square root of 2's. We add the coefficients and we keep that radical the same. All right, that's as simple as it can get. Keep the radical part the same and add the coefficients. And the next one, this example B, we see that the number underneath the radical is different, which is a problem. So don't try to force this and do something that is not right. Instead, think about other things we've previously done. In other words, break down the square root of 27, which would be square root of 9 times the square root of 3. Square root of 9 is 3. Then the other root 3 stays the same. So this problem could be written as 6 root 3 minus 3 root 3. Now, like we did on the previous problem, take the 6 of these root 3's minus those 3, which would give us 3. 6 minus 3 is 3 of the square root of 3's. All right, now let's look at some more examples of these using those same principles. In this number 1, we have negative 2 square root of 5 plus 1 square root of 5. So when we combine those together, we keep the square root of 5. Add your coefficients. Negative 2 plus 1 is negative 1 square root of 5. You can put that 1 in there or not. It doesn't matter. In number 2, we have 4 square root of 10 plus 1 square root of 10 minus 7 square root of 10. So our answer is going to have square root of 10 in it. 4 plus 1 is 5. 5 minus 7 is negative 2 square root of 10. Now, if you wanted to check your answers for these, you could go directly into your calculator, write this in, make sure you're using parentheses around the square roots, see what decimal that comes out to, and then put this into your calculator just the way it is and see what decimal that comes out to. And if they are the same, then you know you did the problem correctly. Number 3, we're getting into a problem that the numbers underneath the square roots are the same. And don't be that person who just says, all right, I'll add them and call this square root of 68. That would not be correct. Instead, you have to break each one of these down. So square root of 9 times square root of 2. The reason why the square root of 9 is helpful is because that is 3 square root of 2. And then as far as the 50 goes, that's square root of 25 times the square root of 2. The reason why that's helpful is because the square root of 25 is 5 times that square root of 2. This plus sign gets carried down. So we have 3 root 2 plus 5 root 2, which would give us 8 square root of 2. So as you're seeing these problems, I'd recommend pausing the video, trying them on your own, see if you can do it without me doing for you first, and then check it on the video later. Number 4, 5 root 3 plus 6 root 3 is going to give you 11 root 3. They already have the same number underneath the radical, which is always nice. Number 5, don't forget that this is a 1 in front of the square root of 7. So 1 minus 9 is negative 8 square root of 7. All right, on to number 6, and we have 4 root 3 that's not going to simplify at all. We've done this square root of 27 a few times. If you recall, it's 3 root 3. And now since they both have the same radical inside of them, we can take 4 minus 3, which is 1, square root of 3. And number 7, 2 square root of 3 isn't going to go any further because the square root of 3 won't break down. However, the square root of 75 has 25 that goes into it. The reason why that's significant is because the square root of 25 is 5. There was a 4 in front of all this, so if we carry that down, 4 times 5 makes this 20 root 3 at the end. And so now when you add those parts together, 2 plus 20 is 22 of the square root of 3's. On to number 8. Square root of 24, it will break down. I'm using square root of 4 and square root of 6 because the square root of 4 is 2. So square root of 24 is 2 square root of 6. Square root of 96 can also be broken down. 4 goes into it, but 4 isn't the biggest perfect square. Instead, 16 is the biggest perfect square. 16 times 6 is 96. The square root of 16 is 4. So this is minus 4 square root of 6 in the middle. And then plus 1 square root of 6 at the end. Now when we add all these together, 2 minus 4 is negative 2. Negative 2 plus this 1 is negative 1 square root of 6. Again, it's not a bad idea to put the 1 there so you know what you're dealing with. And you could put the 1 here. That would be okay. On to number 9. 6 square root of 2 is fine. 3 square root of 8 needs to break down. That's square root of 4 times square root of 2. The square root of 4 is 2 with this square root of 2 after that. Remember, you need to bring down that 3. 3 times 2 means that this middle term here is minus 6 square root of 2 plus, and then we have 2 square root of 32. Breaking this one down, I'm going to use square root of 16 because square root of 16 is 4 with the square root of 2 after that. Bring down that 2 also. 2 times 4 is 8, so it's plus 8 square root of 2. Now, if you add all these together, 6 minus 6 is 0, plus 8 is 8 square root of 2. Again, as I mentioned earlier, I'd pause these videos and try them on your own. If you're feeling good about that, you can move right along. If you feel like you're stuck, maybe go through the video part again to hear some more of the explanation. On to this number 10. And in this one, don't force it if it's not there. What I see here is that the number underneath the square root signs is different. 7 can't break down into anything meaningful. 11 can't break down into anything meaningful. So you have the 5 square root of 7 and the 3 square root of 11 that won't combine. We don't call it prime because we're not simplifying it. The answer is just those two terms added together and nothing can be simplified or combined. In number 11, we have this 6 square root of 3 and 1 square root of 3. Those can combine to give us a 7 square root of 3. Remember, there's a 1 in front of that one. However, then there's this 4 square root of 2. Neither the 3 nor the 2 can break down at all. Because they're different from each other, we can't combine them. So number 11 is going to look like that. All right, down to the last row here. I've seen some of these numbers before. Square root of 18 will break down. Go ahead and do that one. Square root of 50 will break down. Break that one down. And square root of 27 will also break down. So break down each of those individually. Can I pause the video again? Give yourself a chance to try to work that out. So there's square root of 18. This is square root of 50. And this is square root of 27. Now, when we combine these together, 3 root 2 plus 5 root 2 is 8 square root of 2, plus the 3 square root of 3 at the end of it, which can't combine with the other ones. Number 13 has a lot of simplifying to do, and initially none of the numbers underneath the square root are the same. And in fact, they could all be broken down. So pause your video, try to break each one of those down. So the first one's going to be 6 square root of 5. We have plus 2 root 3. Minus 6 root 5. Again, I've seen this square root of 27 a few times. I know that's going to be 3 root 3. So if we combine all these together, 6 root 5 minus 6 root 5 gone. They cancel each other out. 2 root 3 minus 3 root 3 is -1 square root of 3. And there is our solution to the last one.